Okay, so we're going to piggyback off our last problem. In the last problem, we were asked to calculate the molar solubility of FeOH by 2 given its KSP value. And we came up with a value of 2.31 times 10 to the minus 6th molar in our last problem. So now our question is, what is the pH of a saturated solution of FeOH by 2? Now it may look like a very different problem, but it's almost exactly the same problem. Because in order to figure this out, we have to know what the molar solubility of FeOH by 2 is. We had to do all the work we did in the last video and figure out what X is from our ice table. X was the Fe2 plus concentration. So if we had worked the same problem and our question had been this, what's the pH of a saturated solution, we would have to get to X. So re-look at the last video if you need to, but when we get to the X stage there, we're asked about the pH. FeOH by 2 is a base, right? So the molar solubility of FeOH by 2, like we said, was 2.31 times 10 to the minus 6th molar. That means that the concentration of OH minus would be 2 times 2.31 times 10 to the minus 6th molar, because there are 2 hydroxides per formula unit. So the concentration of OH minus would be 4.62 times 10 to the minus 6th molar, which makes a POH that we can calculate, negative log of our concentration there of OH minus, 4.62 double E 6 minus log, and flip the sign, 5.33. Again, don't fall into the trap of thinking you're done, because we want a pH. pH is 14 minus POH, so 14 minus 5.33, 8.66. So you might be presented those problems on an exam. Both of them require that you solve the ice table and calculate the molar concentration of your substance. The first problem we worked just wanted to know the molar concentration. The second one we worked wanted to know the pH of the solution, which required us to find that molar concentration. So we still had to do all the same stuff we did on the last video first, and then recognize that we can get to pH from knowing the hydroxide ion concentration. Okay? So keep your wits about you as you work these problems. They can be a little bit tricky to interpret, but all the solutions are pretty much the same. Okay? Thanks.